Okay.
You're recording your voice right now?
I'm recording everything I do and say.
Wait, the voice too?
Yeah.
So I'm in it right now.
Yeah, you're in it right now, so you can listen to yourself later. Okay, so here we go. The essential understanding for 6-6 day 1. You can add, subtract, multiply, and divide functions based on how you perform these operations for real numbers. One difference, however, is you must consider the domain of each function. So I want you to circle the word domain, and we're going to draw an arrow. Who can tell us what's the definition of domain? Tristan.
No, like one number to another and like the space between it.
You're right. Okay, it's like as far left as far right you can go. Can anybody tidy that up? Joe?
Isn't it like the range or something?
Okay,
Well, that's the
range is
range,
something
yeah.
else. Sarah?
Oh, like negative.
Okay, there it did. Bingo. Okay, Sarah got it. These are the possible x values. I want you to write this down because when you get to rolling on homework and quiz review and you're asked to find the domain again, I want to really encourage you guys to get back to your notes and look at them. Especially these things that I circle and have you write extra stuff. Alright, so let's jump down to problem 1. It says, let f of x equals 4x plus 7. G of x is the square root of x plus x. What are f plus g and f minus g? And then state the domains. Alright, let's do the first one. If I want to do f plus g, another way to say f plus g is f of x plus g of x. Well, f of x is 4x plus 7. G of x is the square root of x plus x. You actually did this in Algebra 1 where you combine like terms. I have 4x plus x, that's 5x. I put a square root of x next and then the constant. So this is f plus g. Yeah.
Why do we have that f and g there?
Okay, do you know how, like, up to this point, if we said y equals mx plus b,
Yeah.
and then if you have a second line, it's hard to distinguish one line from the other. So when I name one f and g, now I know they're two distinct graphs. Like I can name them separately this way. That's all. They're both a y, but instead of saying y equals 4x plus 7, y equals square root x plus x, we're like, which one is the y? You know, which y are you talking about? So we kind of name them with letters so we can differentiate between the two.
So we get back into graphs now.
Sort of. We'll see, okay? Just stay with me here. All right, now, I ask you, what are their domains? So I have, in my tool belt, a special tool.
Carrot.
It is a carrot, and I'm going to get really silly with this, okay? And the intention is to help you. I know what a line looks like, right? Y equals mx plus b. But I've got something in this answer with a square root of x that I don't quite know what that is. So what I do know about square roots is I cannot put a negative underneath a square root, right? Because it gives me an imaginary value. And in this chapter, we're trying to stay in the real numbers. So you set the radicand, in this case it's x, greater than or equal to 0. So on the chalkboard, I've drawn a table. And I want to point out to you, I did not go by ones. Nobody has ever told you you have to go by ones. But like the majority of the time you've ever done a graph, you went by ones because it's convenient. But I want you to notice I put 0 in. The square root of 0 is 0. I put in 1 and got the square root of 1 is 1. I don't want to do 2 because the square root of 2 is like 1.4 something. If I put in 3, the square root of 3 is like 1.7 something. Yuck. I don't want to deal with that. 4 is a nice number. The square root of 4 is 2. And the next nice number is 9. So what I want you to do is I want you to notice on the chalkboard, and for those people who might be watching this, what we've done here, 5, 6, 7, 8, 9. Okay, so what I have on the chalkboard is 0, 0, 1, 1, 4, 2, and 9, 3. a square root function has a starting point, okay? It has a starting point, and then it goes up and up and up, but it levels off. Do you see how flat it is? Okay, so here's my caret, okay? This is a big stretch, but it's goofy, and most students at the end of the year, when I ask them, like, tell me 3 things you remember, they tell me they remember the caret. So here's what I want you to imagine. You know Bugs Bunny, right? And Bugs Bunny loves the big orange carrots. So I want you to imagine that Bugs Bunny is in a garden, and he's like, ooh, I see the green top of that carrot, and I'm going to pull it out. So I want you to watch real carefully. So Bugs Bunny, or you, happens to reach into a garden and pull the carrot out. And I want you to watch the motion of it. Okay, watch the motion of the carrot. Here we go. It's in the ground, so it's got to start. It's not going down forever, because eventually a carrot does stop growing, you know, runs out of nutrients, and it just gets as big as it'll get. It wouldn't grow forever. So here we go. So I start here, and if I lift the carrot up, look at that arm motion. It starts here, it comes up kind of quick, and then levels off. Okay, so here's the stretch. I want you to think of a carrot is a caroot, square root. Okay, caret is a caroot, square root. So I want you to say this with me, okay?
Caroot.
No, we're gonna go caret, caroot, square root. Okay, ready? Here we go. Caret, caroot, square root. Again. Caret, caroot, square root. One more time. Caret, caroot, square root. So I know it's really silly, but it's actually helpful. So if you think of a caret, caroot, square root, you pull it up, it's going to kind of come up, and then it's going to level off. So it's super silly, but it might be helpful. So my domain are the possible values for x. If you look at the graph, you look at this table, it starts with x, and it goes to the right forever. So it's x greater than or equal to 0 is my domain, because I have a square root. All right, now, f minus g. This is the way we say f of x minus g of x. F minus g is the way you say f of x minus g of x. F of x is 4x plus 7 minus. You need to get in the habit of putting a parenthesis around that second function that you're subtracting, because I have to distribute the minus sign. If you fail to put the parenthesis, there's a high probability that you're going to forget to distribute your minus sign. Then I am going to collect like terms, and I get 3x minus the square root of x plus 7. Let me pause a moment here, and let's tie together what we just had on the quiz we took. The square root of x. What's the rational exponent, the fraction exponent for the square root of x? 1/2, right? Okay, so now watch this. Do you remember earlier in our polynomial chapter, we talked about polynomials in standard form. That meant highest power down. This is not a polynomial, but we can still kind of follow along standard form. 3x is x to the first, square root of x is x to the 1/2, and then I have no x, okay? Now, domain. Domain are the possible values I can plug in for x. I have a square root again. We don't need to do the work twice. We know the square root is going to be x greater than or equal to 0. When the radicand changes, that's what's under the radical. You're just going to take the radicand greater than or equal to 0. All right, let me pause and give you a head start. Try the got it. F of x is your 2x squared plus 8. G of x is x minus 3. Do f plus g and the domain, and then do f minus g and its domain. Okay, try to got it. This next piece of paper I'm passing out, This is the graphing. This is not your homework. But just set it aside until we're ready to go over it.
Carrot, root, square root. Did you know if you eat a carrot, it'll make you see better?
I have heard that.
It also make you turn orange.
F plus g. So we're going to do f of x plus g of x. 2x squared plus 8 plus x minus 3. So that's 2x squared plus x plus 5. Now let me ask you something. What is the shape of that answer if I had the graph of it? Not precise, but just generally speaking, what is its graph? A parabola, right? This is just an x squared, so it's going to be a U shape. Does anybody remember from chapter 4? If domain are the possible values of x, and I think Tristan said something about like it's from one part of the graph to the other, like one side to the other. That's graphically kind of a good way to think of it is how far left does the graph go? How far right does the graph go? On a parabola, how far does it go? Negative infinity to infinity. You're absolutely right. So, x squareds always have domain negative infinity to infinity. F minus g is f of x minus g of x. So I have 2x squared plus 8 minus the quantity x minus 3. If I ever go too quickly for you, you can go back. I'm recording this so you can watch the video, fill in anything. Or if you start the homework and you feel a little bit confused, use one of your resources. Go back, watch the video, pause and rewind as many times as you need. So this is going to give you 2x squared plus 8 minus x plus 3. I'm going to collect like terms. Be careful on the subtraction. You've got to subtract the entire second function. Sometimes, if it's more than one term, you'll have to distribute the subtraction sign. This is also a parabola. My answer is a parabola. So the domain is negative infinity to infinity. When you're ready, flip the paper over. And above problem 2, we're going to write down two things. At this point in the year, the only two types of functions that we need to be concerned with, because we've done lines, parabolas, absolute value, and polynomial functions. They all have domain, all real numbers. There are two functions now that we have to be concerned with. In domain, if you have a square root, and we're going to call it square root with the radicand, the domain is always the radicand greater than or equal to 0. Now, it's only when you have a square root. The other area is if you have a fraction. In a fraction, your denominator can't equal 0. So when you're working with functions, and we're adding, subtracting, multiplying, and dividing them, if you have a square root, and you want to look at the domain, you set the radicand greater than or equal to 0. If you are adding, subtracting, multiplying, and dividing functions, and you have a fraction, your domain cannot have the value that makes the denominator 0. Otherwise, it's all real numbers. Later in the year, we're going to talk about logarithms, we'll do some trig functions, and we'll have other domains to worry about, but you don't know about that yet, okay? So up to this point, Those are only the two types that we have to worry about. Square roots and fractions. Otherwise, your domain is all real numbers. All right, so let's look at problem 2 now. F of x is x squared minus 9. G of x is x plus 3. F times g means f of x times g of x. All right, so f of x is x squared minus 9. G of x is x plus 3. Hey, we've done something like this before. What's the technique we've used to multiply this type of problem? Beautiful. FOIL. You're going to FOIL it. So we're going to take x squared times x, that's x cubed. The outer is 3x squared. The inner is minus 9x. And the last is minus 27. You should pause and think, can I collect any like terms? Are there any like terms? No, so that's my answer. I am asked for the domain. Do I have a square root anywhere? No. Do I have a fraction anywhere? No. So what's my domain? Say it again, I can't hear her. Negative infinity to infinity. All right, f divided by g means f of x divided by g of x. So that's x squared minus 9 over x plus 3. When you deal with a fraction, the first step, when you set it up, immediately stop and set the denominator equal to 0. If I subtract 3, I get x equals negative 3. So that means my domain is it's everything except negative 3. Now, you cannot cancel x squared and x and the 9 and the 3. You cannot do that. That does not work in general. What we've talked about over and over and over again this year is you can only cancel factors. So, if you remember the King Kong riddle I gave you, that involved a lot of factoring and unfoiling. Look at my numerator. X squared minus 9 factors as a difference of two perfect squares. X squared minus 9 factors into x plus 3 times x minus 3, and it's going to cancel to x minus 3. Now, I had somebody last period who canceled and said, hey, I got x minus 3. That's just a coincidence. It does not work in general. You cannot cancel the x squared over x and the 9 and the 3. It did happen to work that way here, but it does not work in general. You'll get the majority of your problems wrong.
So if it doesn't work in general, is x squared minus 9 over x plus 3 just your answer?
No, I just factored it, and then I can cancel the common factors. Okay?
Okay.
So it just, again, like, so say I had, for example, suppose I have x squared plus 7 over x plus 14. Okay? So if you're trying to make that x over a 1, right? And maybe this 1 over 2, so you think that's x plus a half? So guess what? X is a placeholder for a number, right? So if I plug in x is 3, 3 squared is 9, 9 plus 7 is 16, 3 plus 14 is 17. That is not 3 plus a half. Again, it is merely a coincidence that it reduced this way. It's just like a weird, I'm going to like change this next year because that's a bad example. It just does not cancel that way. All right, try the got it number 2. I'll give you a short head start on me. Do the multiplication and the division. State the domain. So do as much of it as you can. You should be able to do a little bit, okay? Should be able to do some of this. All right, if you're struggling to get started, let me refresh your memory on this multiplication. You take 3x squared minus 11x minus 4 and multiply it all by the 3x. So that's 9x cubed minus 33x squared minus 12x. So you're using what's called the extended distributive property. It's not FOIL, because FOIL is 2 terms times 2 terms. Then I'm going to take everything in here times a 1. So that's a plus 3x squared minus 11x minus 4. Then you collect like terms. So I get 9x cubed minus 30x squared minus 23x minus 4.
Yeah.
You are asked to find the domain. Do you have any square roots here? No. Do you have any fractions? No. So my domain is negative infinity to infinity. Okay, f divided by g is the same as f of x divided by g of x. So I'm going to take 3x squared minus 11x minus 4 over 3x plus 1. I do have a fraction. I stop right here and do my domain. So to do the domain, you're going to set the denominator equal to 0, because this is the value or values in some cases that you cannot plug in for x, because it would cause you to divide by 0. So I subtract 1 and divide by 3. So my domain is x can't be negative 1/3. Now, I cannot cancel 3x squared with 3x, okay? You can't cancel terms. All right, so now, there's a method to my madness. I had you practice that unfoiling, foiling stuff on the King Kong riddle. And I hope you actually did it the right way. I'm going to see if I can factor 3x squared minus 11x minus 4. So you take 3 times negative 4. I'm looking for 2 numbers that are going to multiply to negative 12, but add to negative 11. Can you think of 2 numbers that do that? Yeah, Joe? Peyton, what do you think?
Why negative 12?
You take 3 times negative 4, the A times the C. Amber? Negative 12 and positive 1. So that's going to do the job for me. So watch what's going to happen. I'm splitting the middle. We did this back in chapter 4.
Back in the day.
Back in the day, 3x squared minus 12x plus 1x minus 4. I do need to remind you, everything we've learned, we use again. It just comes up 1 chapter later, 2 chapters later. And that's why, so the King Kong riddle, I know you're probably like, okay, where's that coming from? hey, your teacher knew we needed to factor, so I had you practice a little bit there. All right, so I'm going to factor by grouping here. The second pair don't have anything in common, so you have to remember to put a 1 there. So that's x minus 4 times 3x plus 1. This one I think is a much better example than the one before because you can clearly see why the 3x squared and x don't cancel, like it just doesn't. So I'm getting x minus 4 as my final answer. We will spend more time on fractions, they're called rational expressions, in chapter 8. But what I need you to just know is the basics. In a fraction, you factor it and see if you can cancel any common factors. Ooh, I'm not done. All right, do you have that graph paper I gave you?
Heck yes.
It says 6, 6, I think number 1. So this really is the same thing as what we just did, but we're going to look at it graphically. So the first thing I want you to notice, this is the second sheet of paper I gave you. There's a bunch of graphs on it. The top left graph says f of x. The top right graph says g of x. I'm going to do number 1 with you, and then I want you to do 2 through 9. I want you to finish the whole way on your own, and then we'll go over it together. So number 1, find f of 0 plus g of 0. All right, so look at f for me. F of 0 means x is 0. So if I go to x is 0, what number is the graph located at? Where is it? If x is 0, where's the graph? It's at 4. So this value inside of f, and now watch this beautiful connection. Do you remember when I had you get the marker boards?
No.
And we did f of 2, we did f of 0.
Past period.
Oh, okay, do you see this? We had to practice this. Now I'm going to go to g of 0. So I go to the g graph. G of 0, where's the graph located? 2. So f of 0 plus g of 0 is 4 plus 2, which is 6. All right, try the rest of them. They go pretty quickly. Do as many of them as you can. There might be a couple that you see divide by 0, and that's a problem. Right, just to check in with you to make sure we're going on the right track. F of 2 is up at 5. G of 2 is at 0. So number 2, did you get 5? Yeah, all right, good. Now, F of 3. I go to F of 3, that's 2. This is a times sign. G of 3 is 4. So number 3, you should have 8. Number 4, g of 0 is 2, f of 0 is 4. We reduce all fractions, so reduce that to 1/2. F of 4 is 0, okay, here's f of 4, the y value is 0. G of 4 is 5. 0 plus 5 is 5. Number 6, g of 4 is 5. F of 4 is 0. Okay, you can write one of 2 acceptable answers. Does not exist, DNE, or undefined. It is not acceptable to put no solution. This is not an equation. Solutions are reserved for equations. Any questions on the top half with those graphs? All right, down in the bottom, I changed the graph, so I gave you an F and a G. F of 1 is 1. G of 1 is 1. So number 7 is 2. F of 1 again is 1. G of 1 is 1. 1 times 1 is 1. F of 0 is 0. G of 0 is 0. You cannot divide by 0. It is considered to be undefined. All right, that concludes the notes.